So let's take a look at our first time of using some logarithms to actually solve something or expand something. So here we have expand each logarithm using the product law. So we have log and then base 10, so it's our natural log, and then brackets x times y. Well, when we're multiplying two things inside of our log, that means we can actually split this into two logarithms. So it's going to become log x plus log y. Okay, that's not so bad. Let's check out the next one. So here we have log base 10 and then brackets 10x. Well, this is a multiplication between the 10 and the x. So I can again use my product law and rewrite this as log base 10, so log 10 plus log x. We're actually not done here though, because right here we have a base of 10 and our argument is 10, which means this is equal to 1. So this is actually 1 plus log x. All right, our final one. So here we have a logarithm, but we have some multiplication nested inside of here and with an addition as well. We've got to be a little bit careful. So this multiplication 3 times x plus 1, I can split that into separate logs. So we have log 3 plus log x plus 1. Now it might be tempting to actually break this apart even further, but just like exponent laws, we don't actually have log laws when it's addition. So we're done here. All right, now we're going to go the other way. So we're given something that's been expanded and we want to write it as a single logarithm. So we have base 10, so they do have to be the same base, and we've got an addition between these logs. Well, that means I can actually go the other way and say this is actually log 3 times 4, which can be simplified even further into log 12. So same thing here, same base for both of them. So we can use our product law, and so we can turn this into one logarithm. So it's going to become x squared times x cubed. And because we have the same base, multiplication, we can actually add those exponents, so it becomes x to the power of 5. All right, for our final one, so here we have an addition of two logs. So we're going to take the arguments and multiply them. So x plus 1 and then x minus 2. Now we could FOIL this out, but there's really no reason to. It might be more useful in factored form, and so we're going to leave it just like that. So we're going to look at a different law now, the quotient law. And the quotient law says that when we have a division inside the logarithm, we can actually split that log into 2 with a subtraction. So this becomes log x minus log y. The most important thing here is our denominator is always going to be what is being subtracted off of the other log. All right, let's look at the second one then. So again, we have a division, so we can split that up or expand it. So it becomes x plus 1 minus log 100. Now this log 100 can be simplified more. We can't do anything more here because that's still, it's an addition sign, so it stays as x plus 1. But this can be rewritten as 10 squared. Now there is that log rule that says if our base and our argument are the same, then this exponent is what it actually becomes or evaluates to. So then we get this is actually equal to 2, this exponent right here, because the base and our argument base is also the same. Both bases are the same. All right, and our final one here, a little something I'm going to watch out for. We actually have a base that's not just 10. So I'm going to have log, and I can split this apart into log x, now that is base 3, minus log base 3, and then we have 3 times x plus 1. Now here we can use the second log rule. We can go back to the product law, and we can split this, expand this even further. So we're going to get log base 3 of x minus log base 3 of 3, and then we're going to go plus our second part of that log, which is x plus 1. All right, example 4, write as a single logarithm. So we're just going opposite way now, so instead of expanding, so we have something with a log with the same base and a subtraction, meaning we can go and divide the arguments of both these logs. So it's going to become log 12 divided by 4. Whatever the second log is, that always becomes our denominator. That can be simplified further to log 3. Looking at the same next one, we have a base of 10 here, and we have a subtraction, so we're going to divide. So it becomes log x to the power of 5 divided by x squared. Exponent law says when we're dividing same base, we subtract the exponents, so it becomes x to the power of 3, or x cubed. Our final one, here we have to use the product law and the quotient law, so we're going to go left to right. So first I'm going to do this plus, which is a multiplication inside the log, so it becomes 2x, and we still have this minus log x plus 3. And then when we have the same base and a subtraction, it's going to become a division inside of that log. So it's going to become 2x and then x plus 3. And now it is written as a single logarithm. Moving on to example 5. So expand using the power law. This one's pretty simple. When we have log base 10 of x and then to the power of 2, this 2 is going to become our new coefficient of the log. It's going to become 2 log x. Simple as that. Here, same thing. We do it individually to each log. So this 3 is going to become here. So it's going to become 3 log x. And here the 4 will become 4 log x as well. Finally, this one could be a little bit trickier. There is a bracket here. So when you go and bring it to be the coefficient, you're going to want to make it sure it's a plus 1 log x. Now you could expand that further, and it would be a log x plus log x, and that's using the distributive property. If you've been following along, you probably have a little bit of deja vu here, because you know we're going to now write this as a single logarithm. So this time we're going to take this coefficient, and it's going to become our exponent of our argument. So it'll become log base 10 still, x cubed. Here, this 3, be very careful, it is going to go on the outside of this bracket. So it is going to be log, and then we have 2x squared cubed. Now, because this is multiplication inside of here, we could actually distribute that 3, and it will become a log. So then we're going to have, well, this is an exponent 1, so 1 times 3, so 2 cubed. And then 2 times 3 is 6. Now 2 cubed is actually 8, so then we get log 8x to the power of 6. One last one. So we're going to take this 5, it's going to become our exponent, so we'll go log x to the power of 5, and then 3. Notice I'm leaving the negative there, I'm just taking the number. So then it becomes, sorry, not 3, but in fact just log x cubed. Now we do have a subtraction between two logs with the same base, which means that I can do a division on the two arguments. So I'm going to have log x to the power of 5 and x cubed. I can do a subtraction of the exponents there, so I get x squared.